Hello and welcome to the MixOps demonstration series, where you can see live demonstrations for real users and real-world applications. For more information about our products or to schedule your own live demonstration, just give us a call or visit us at www.mixop.com. This video shows the VisualCAM 2016 for SolidWorks TURM module being used to program turn roughing, finishing, and drilling operations. Without further delay, we invite you to sit back and enjoy the demonstration.
Now, for the turn module, I'm going to basically just save a copy of this part in here. I'm going to do a save as, and I'll just call it turn. I could still program both operations on the same part, but I'm just going to save this as a turn so I can suppress out some of these features in here, right? So I could suppress this feature right here, and also I could suppress this one right here, and these features also, because they're not required for the turning process. Am I correct?
Yes.
So we got these features for turning. Let's go ahead and just save the part. And when I go back and just reopen this part, you will notice that it only shows the two features that you have, the revolve, and you still have the milling operations programmed on it. So I'm going to switch the interface from mill over to the turning module. So you can see that the interface automatically switches. The browser is now changed over to the turning module. So the first thing we want to do here in the turning module is you'll notice that by default the world X coordinate is oriented to the turn Z coordinate, and then the world Y coordinate is oriented along the turn X coordinate. So the part is automatically oriented in the intended direction for turning, right?
Yeah.
So what we do in the first step here is we go into the lathe coordinate system. In case you need to change it, you can use these controls in here to change it. In this particular case, we got it oriented correctly. So the next step is we define the part. So we can click on part, and then we select the part. We can use select surfaces, and I can just do a Control A to select all those features, accept it, and then hit save. You'll now notice that the part is automatically defined. You can see the part profile being defined right there.
Yep.
You see that, sir?
Yep.
Okay, great. So now we're ready to program the toolpath. So let's go ahead and select the post processor in here. And you said it's a Fager controller?
Yes. 8037, but it's the same as the 55, just with a smaller screen.
Okay, I may have an 8037. I don't see it on this list, but yeah, we can use 8055 for the demonstration in here, and I can go look for an 8037. I have one on the list. So as long as your machine controller can read standard G code, we will be able to edit and write new posts in here. So this is how we go about creating new post process. Okay?
Yep.
All right. So we'll set the extension to .nc. In the next step, we want to define our workpiece, the blank. We can do a cylinder stock, and here we can see that the system automatically determines the radius and the length. You said your blank would be 5.5, and you want to make sure the stock blank is at least 1 inch, right, or longer. So it doesn't matter how long it is. You can even put in like a 2-inch blank. For now we can just say 1 inch. Now we can view the stock either as a full view, or you can look at it as a 3/4 view. So you have an option to look at the stock display either as a full blank, a cylindrical blank, or just like a sectional view, like a 3/4 view. In the next step, we want to align it. So we can say align, and we want to have it flush to the rightmost face. Okay? And then we pick the material for it. So you select the material. In this case, it's going to be the same as what we did for the milling module. It's going to be 1030, the mild steel, and there it is. And then we want to put the work 0, which is your program 0, to the rightmost face. So there's your XYZ origin right there. There be any questions so far?
No, so far so good.
Okay. Next step is to program some toolpaths in here. So we can go to turning, and we can select roughing. And you can specify insert that you'd like to use. We have diamond inserts, triangular, circular, trigon, different types of inserts. So I could say I want to do an OD operation, so maybe use a diamond insert in here, set the orientation to outer diameter forward cutting. You can also go into your feet and speeds, where you can set the feet and speeds. You can either work in inches per minute or you can work in inches per revolution. You also have the built-in feet and speeds calculator in here. So once you have the tool selected, the next step is to go specify your feed speeds and the turning parameters. If you'd like to restrict or contain toolpaths, you can specify containment in here. And based on the tool orientation, the approach type is automatically being either set to OD or facing. So we set it to outer diameter. We can specify the parameters in here for your roughing cuts. And if you do not want to do a final cleanup pass, you can clear this out and then select generate. So here you'll notice that it automatically did a roughing for these areas. So we can go ahead and run a simulation in here. And there's your turn roughing. Now if you change the approach type in here from OD to face, you'll see that the cut pattern, the cutting type would change right there. You see that, sir? So basically use a facing operation. And you can also restrict the toolpath so it doesn't cut into some of these areas. So you can go ahead and specify an area to contain the toolpath. So if you actually go over here, you can actually change how you want it to be restricted to. You can also specify a section to avoid, or you can pick an area to restrict the toolpaths. You can go over to global parameters. You have an option to select containment, where you can actually pick start and end points like containment areas to restrict the toolpath, and then you can go generate the toolpath on it as well. So in order to pick containment, you would need to basically define a sketch, or you can pick 2 points to restrict it. So for example, in the turn roughing, I could select a containment in here to start at this point right here, and I can go stop it right up here. So that's a containment rectangle I can set, and you'll notice that the cutter path will stay only to that area. Any questions?
Nope.
Okay. Now if I want to go back and do this as the OD operation, I can make a copy of this operation in here, paste it, and in the turning module, the system automatically takes into account the in-process stock. So I'm going to clear the containment and change from front-facing to outer diameter and generate it. You'll now notice that it only does these sections in here. And if there was any material being left from the previous process. Right there. Now you want to program a finishing toolpath for it. Go to turning and select finishing. You can use the same insert. In the global parameters, you can pick the start and end points. You can select you want to start right up here, and you want to go all the way up to this edge right here. You can pick those 2 points and generate it. And there is your finishing toolpath. There it is. Any questions so far?
Nope.
No.
And now you want to program these features. We could use a turning, and you can use the ID operation, roughing, and we can use the insert to be ID, specify the parameters, and generate it. So you can see that it automatically does the ID toolpath for these. Now if you already had a pre-drilled hole in here, so this particular is 4 1/4 inch, so is the blank that you're going to be starting with, does it have a pre-bore on it typically?
No, it's going to be plain.
Okay, so are you going to be boring this in a turning operation, or would you want to use a milling operation to bore the hole?
No, we're going to bore it in the lathe, right?
But it looks like you will have to one face of the board somewhere else. But not facing.
But we're going to have to do one face on one end, but then we can use the bore as the reference, and then we turn around the piece and we face the other one and we do the counter bore on the other side, right?
Okay, makes sense. Yep, you're right. So what we can do is we can first start off with a drilling operation and maybe use a drilling tool. So here I have a 5/8 drill bit. I can use even a larger tool, and I can go ahead and specify the total depth I want to cut is go from here all the way down to the back face of the part, right? And if you want to make it a through hole, you can say add tooltip to drill depth and generate it. So that basically creates a drilling operation in here.
Okay, but here if you're facing both faces on the CNC lathe, it allows, so that blank should be centered in, right, the punch should be centered in. Right now we don't have machine gun.
I'm sorry, I didn't hear that, sir.
Yeah, I see what you're saying. Yeah. But that's fine. That was just for
Okay,
demonstration.
for that one doesn't matter.
Yeah. Oh yeah, when we do it in reality, we have to center it so we can, because it's going to be raw cut from the bandsaw, so we cannot trust the face. We're going to have to machine that from the instruments. Yeah.
Okay, so you want to face this out first in here? Is that what you're saying?
But now what I was saying is that you will have to start with the part centered in the middle of the blank, because we will have to face both.
Okay.
Yeah.
Okay. Yeah, we can even do a facing. Instead of doing an OD, we can do a face operation first to basically plane it down, and then we can start off with other operations. That's also we can do it. That shouldn't be a problem.
Yeah.
Now we just programmed the drill operation in here to bore the hole initially, and now if I go back to the turn roughing operation, and if you notice here, I can change any of the parameters in here. And if I do a generate on it again, you'll see that it knows that there isn't any material in here. It's already been drilled out, so it's not cutting air, and it's only machining where there's material.
Yeah.
That's your ID roughing. Now once you're through with the ID roughing, you can go with an ID finishing operation with the same insert. You can select the start and end points. You can specify where do you want to start. You can say you want to start right here, and you would like to go back all the way back to this edge right in here. And that'll give you an ID finishing toolpath. There it is.
We hope you enjoyed this addition to the MexOpt demonstration series. For more videos or to download and test drive any of our products, feel free to visit us online at www.mexopt.com. Thank you.